Okay, now we're going to look at what happens when we have amines and we expose them to nitrous acid, HNO2. Remember naming acids in Gen Chem 1? Takes you back to the good old days. Yes, nitrous acid. Okay, now nitrous acid, not a good thing to ship. It's pretty reactive. It's kind of nasty. And so you're going to buy this sodium nitrite. So if you have sodium nitrite, but you just easily get in the lab react with HCl, it's got a lot of that, good and cheap, then you generate the nitrous acid plus NaCl. And the interesting thing is, if you really got a nice amount of HCl here, this nitrous acid plus the HCl is going to form this beast here, and we've got a good leaving group, or protonating that OH, got a good leaving group, and it generates H2O plus this nitrosonium ion. And this nitrosonium ion is a good electrophile. And nitrosonium ion, a good electrophile, primary amines, good nucleophiles, you form these diazonium salts. We call it diazotization. Nice word. Okay. So the deal is, when you're doing all of this to get the nitrosonium ion, it's so crazy you don't separate out any products. You just generate this and then you use it right away. So if you have this primary amine, you just say, okay, I'm going to add my sodium nitrite and HCl, knowing that this will generate the nitrosonium ion. And then what you get is R bonded to the nitrogen, triple bonded to another nitrogen with the Cl. This is the diazonium salt. All right. So, for example, if you have aniline and you react it with sodium nitrite and HCl, you just form the diazonium, the nitrogen-nitrogen triple bond, and the chloride right there. Down here is the mechanism of the reaction. Frankly, we're getting late in the game. I don't care about if you know this mechanism. I will not test you on the mechanism of this reaction, but there it is. Face it, this summer, it's going to be the middle of June. You're going to be lonely for Organic 2, and you're just going to review the notes and say, you know what, I think I really need to learn that mechanism. Well, there it is for you. Okay, so you make the diazonium salts. What is it good for? Well, let's see what it's kind of good for. This is going to get fun. Alkyl diazonium salts. You have like a tert butyl group, so you've got this tertiary amine, or no, it's still primary amine, good heavens. Only one R group on that nitrogen, still a primary amine, but it's a tert butyl group here. You make this diazonium salt right here. It's unstable. It's an explosive in the dry solid form. Yeah, so let's not make that, shall we? I'm not always fond of making something that explodes in the glassware while you're trying to pull it out of the glassware. Question: why is this so good? Why does this explosion happen? And if you're looking at our diazonium salt, you're probably thinking to yourself, wait, nitrogen-nitrogen triple bond? That's pretty close to N2 gas. And that's the deal. It does make N2 gas. Triple bond, very stable. You make a very stable N2. You'll find that that is part of the deal with lots of explosives, is that you make N2 molecule very, very quickly. TNT, trinitrotoluene, also makes N2 gas very, very, very quickly.